Hi, welcome to Python Polygon. This is going to be the second topic in the Aptitude series, and this is going to deal with work and wages and rates. Okay, so let's start with the initial formulae. So basically, when you try to compare persons working, you can use this formula. Okay, where M1 is like say this is group 1 and this is group 2. So if you want to compare two groups working, you can write it as the number of workers in group 1 into the number of days they take to complete into the number of hours they work into the efficiency per worker divided by the unit of work of the first group is equal to the similar pattern here, number of workers into days into number of hours working in a day into efficiency of the worker divided by units of work in group 2. What this means we'll find out in the when we solve the questions. Okay, so basically this is not that important, it's not required that much. Okay, fine. In the next one you can also have the similar case, but when you add a lot of different values you can change the number of workers and efficiency per worker here. Okay, that's what it means. So let's directly dive into the questions. The first question says that two friends A and B were employed to do the same work. Okay. Initial deadline was fixed at 24 days. Both started working together, but after 20 days, A left the work and whole work B took to 30 days to complete. Okay. In how much time can B do it alone? Okay. See, in the beginning, when you have that two friends are working together or two employees are working together, you have to always think about rate. Okay. Rate is work done per unit time. Okay, so basically what this means is if uh, see if two friends are working together, their rates are added, right? So rate of the first guy A and rate of the second guy B is equal to something. Okay, now the work that A and B do together is completed in 24 days. Okay, so if it's completed in 24 days, the per day, the work they complete per day will be called their rate, correct? So rate will be nothing but RA plus RB will be 1 by the work they complete. Okay, so 1 by 24. Okay, so this means they do 1/24th of the work every single day. Okay, this is a per day. Okay, so they do 1/24th of the work per day. Fine. Now they started working together with this rate. Okay, with this rate for 20 days. Okay. See, in one day, if they can do 1 by 24th of the work, okay, at the end of 20 days, how much work is completed? It's a simple cross multiplication. Okay. So you get 20 by 24 of the work is completed in 20 days. Okay. After this, we have to find out how much work is left. Okay. How much work is left? The work left is 1 always because it is work we are considering as 1. That is one job they have to do. So it is 1 minus 20 by 24th of the work is done. Okay. Which is 4 by 24. So this is nothing but 1 by 6 of the work is still left. Okay. That the B working alone takes 30 minus 20 days to complete, correct? Because after 20 days he starts working alone. So it takes him 10 days to complete 1/6 of the work. Okay. So we have to find out the rate of B. Rate of B is nothing but the work he does in one day. Correct? So if it takes him 10 days to complete 1/6 of the work, in one day how much does he do? This is nothing but RB. Okay. This is basically RB. So we cross multiply again. In this chapter, you will notice you cross multiply a lot of times, and that's a good thing because you can make all kinds of relations and cross multiply and get the answer very simply. Okay, so basically, you get this as 1 by 60th of the work is done per day. Okay, so if rate of B is given as 1 by 60, the question is how many days, how much time can B finish the work alone? Okay, imagine A was not there. How much time would it take for B to finish the work? Okay, If in one day he can do 1 by 60th of the work, how many days does it take him to do the whole work? So you just cross multiply. Again, you'll get the answer as 60 days. It's pretty obvious because in one day he finishes 1/60th. So in 60 days he'll finish the whole work. Okay. So the answer is 60 days. Okay, the next question. A and B took a job to be completed in 20 days. Okay. What does that mean? Work of A and B would have been 20. Okay, this is the answer. This is the first part. They started working together, but after 12 days, C joined them and finished the whole job, which was first scheduled for 20 days. Now they finished the whole job in 15 days. So how much time would C require to do the job alone? Okay, if C was hired alone, we have to find this out. See, first we have to find out how much rate of A plus rate of B was, because we need to know how much work they did per day to calculate how much work they did in 12 days. Okay, the scenario is simple. First, A and B were working together. Okay, they did this for 12 days. They were supposed to complete the target in 20 days, but C joined. Once C joined, the work finished in 15 days. Okay, this is the setup. Now, what we need to know is rate of A plus rate of B we need to find. Okay, if they can do, again cross multiply, if they can do the whole job in 20 days, how much can they do in one day? Okay, this is becomes 1 by 20. By this time, you should know that rate is nothing but 1 by work because it is per time. So it is 1 by work, hence this is nothing but per day. Okay. So rate of A plus rate of B was 1 by 20th per day. Okay. So they finished 1 by 20th of the work per day. Now, if you have that 1 by 20th of the work per day, how much work do they finish in 12 days? Okay. So in one day they finish 1 by 20th. In 12 days, how much do they finish? Simple, they finish 12 by 20th of the work. Okay. Now this is nothing but 3 by 5. So 3/5 of the work is done. Okay. How much of the work is left? 1 minus 3 by 5 is left. Correct. So that is nothing but 2 by 5. 2/5 of the work is still left. Okay. Now uh, this 2/5 of the work is done in from day 12 to day 15, that is in 3 days. Okay, so the work done by A, B and C took 3 days to finish 2/5 of the work. Okay, we need to find out the rate again for this. So in 3 days they finished 2 by 5 of the work. So to finish the whole job, how many days does it take? 1 means the whole job. Okay, so once we find out how many days does it take, we can find out the rate of A plus rate of B plus rate of C. From the above equation, we know rate of A plus rate of B is 1 by 20. So we can find rate of C. If we find rate of C, we can find out the work that the number of days that C takes to finish the whole job. Okay. So let's continue. Uh, in 3 days, they can do 2/5 of the job. In how many days it will take to do the whole job? Okay. Again, cross multiply. You get the answer as 3 by 2. So basically 15 by 2. It takes them 7.5 days to finish the whole job. Okay, so what does that mean? A, B, and C can finish the whole job in 7.5 days. Okay, so what is rate of A plus rate of B plus rate of C? It's nothing but 1 by 7.5. Correct? So if this is 1 by 7.5 and rate of A plus rate of B is nothing but 1 by 20, so what is rate of C? Rate of C is nothing but 1 by 7.5 minus rate of A plus rate of B, that is nothing but 1 by 20. Okay, so this comes as, I'll just do it. So 1 by 7.5 minus 1 by 20, it comes as 1 by 12. Okay, if rate of C is 1 by 12 of the job per day, okay, basically C takes in one day, it does 1 by 12th of the job. Okay, so in 12 days, it's pretty obvious it will finish the whole job. Hence, if C only was hired, it would take her or him 12 days to finish the job. Okay. Again, what we did from the starting, we found out the rate of A plus rate of B. Okay. Always for work and this work questions, find rate. Okay. It's going to be very simple after you find rate of doing work. Okay. So yeah, we found out rate of A plus rate of B. Then using the additional information, when C joined, we found out the rate of A plus rate of B plus rate of C. Once we got that, we substituted the value of rate of A plus rate of B, we got rate of C, which is nothing but 1 by 12. So if C finishes 1/12 of the work every day, it takes 12 days for C to finish the whole job. Okay. Next question. Three people A, B, and C start working individually. They can finish the job in 10, 12, and 20 days. Okay. They decide to work together, but after 2 days, A leaves the job, and after another day, B leaves the job. Okay. If they get 2 lakh collectively for the entire work, find the difference between the highest and lowest share. Okay. This is a pretty long question and it is a little tricky to understand. So we have to first write down what we know. Okay. So basically what we know is A can finish the job in 10 days from the question. B can finish the job in 12 days. C can finish the job in 20 days. So by this we can simply write rate of A is 1 by 10. Rate of B is 1 by 12 and rate of C is 1 by 20. Okay. Now they decide to work together. After 2 days A leaves. Okay. So for 2 days they work together. If they work together, their rate becomes RA plus RB plus RC. So it becomes 1 by 10 plus 1 by 12 plus 1 by 20. This is nothing but 60 as common denominator. 3 times, 5 times, 6 times. 5 plus 6 is 11, 11 plus 3 is 14. So 14 by 60 is 7 by 30. Okay. So rate of RA plus RB plus RC is 7 by 30. If they could do 7 by 30th of the work in one day, they did twice of that in 2 days. Simple. So they did 14 by 30th of the work in 2 days. That is nothing but 7 by 15 of the work in 2 days. Okay. After that, A left the job. A left the work. Okay. So what I recommend is first we find out. I mean, we note down how much work everyone did. Okay. So A, B, and C. In the first 2 days, A did twice of its rate because it worked for 2 days, so it did twice of its rate. That is 1 by 5 of the work. In this first 2 days, B did twice of this, so it is 1 by 6th of the work. And in the first 2 days, C did twice of this, so that is 1/10 of the work. Okay. Next, A left the job, hence we don't add anything here, and we calculate only how much B and C have done the work. Okay. So that is 1 by 10. Yeah. Now A left the job, so we calculate how much time it takes, how much work that B and C can finish in a single day. Okay, that is nothing but RB and RC. So they do work only for one day together, B and C. Okay, so that becomes 1 by 12 plus 1 by 20. That is nothing but 5s are 3s are 8 by 20, 8 by 60. 2 by 15. So in on the third day, RA and RB and RC do 2 by 15th of the job. Okay. If 7 by 15 is done on the first day, 2 by 15 is done on the second day, 9 by 15 is done totally, right? 9 by 15th of the job is done totally. Okay. We need to understand the question properly. Okay. What we need to find is not how many days they took to do the work, but how much work each person did. Okay. Think about the people doing the work. Okay. So as of now, A doesn't add anything. B and C have to we have to add the work they did. So B did 1/12 of the work on day 3 and C did 1/20 of the work. Okay. After this, B left the job and C completed the whole job. Okay. So after 9 by 15, C did how much of the work is 1 by minus 9 by 15, correct? So if you take this side, it becomes 6 by 15. So C did 6 by 15th of the job. In how many days we do not care. Okay. So we add 6 by 15 in the C column. Okay. So basically they are paid 2 lakh for the whole work done. Okay. 2 lakh for the entire work. Now we calculate how much work A did. Okay. A did only 1/5 of the job. Okay. B did 1/6 plus 1/12 of the job. So that becomes 2, 3, 3 by 12, 1 by 4. 1 by 4 of the job. And then C did the rest. Okay. If this number comes as 1 minus 1 by 5 minus 1 by 4 will be right. Okay. That is nothing but 1 by 10 plus 1 by 20, and we add the last part 6 by 15 this side, so you get this as 11 by 20. Okay, to cross verify and see that the work is done completely, we add all these. Okay, if you add all these, the LCM becomes 20 and this becomes 5 4 times 5 times 4 plus 5 plus 11 is 20. 20 by 20 is 1, hence the work is done properly. Okay, in this, who has the lowest work done? A has the lowest work done and C has the highest work done. Okay, this is the lowest, this is the highest. So it's pretty apparent that C will get paid the most, A will get paid the least. Okay, we have to find the difference between the highest share and the lowest share. Okay, so if C did 11 by 20th of the job, C gets 11 by 20th of the money. So that is nothing but 11 by 20 into 2 lakh. This becomes 10,000, and then C gets 1 lakh 1,000. Sorry, 1 lakh 10,000 is the amount C gets paid for doing the work. Okay, and the amount A gets paid for doing the work is 40,000, because 1 by 5 into 2 lakh is this goes 4 times and 40,000. Yeah, so the difference between these two is nothing but 70,000. So that is your answer. Highest and lowest share, the difference is 70k. This was pretty long, and we need to focus on the amount of work done and not the number of days taken. Okay, so basically C did 1/10, 1/20th, and 6/15th. Okay, the next question: A alone and B alone can do work in 18 and 8 days more than both working together. Okay, find the number of days required if both work together. So okay, now what the question is saying is A number of days A takes is equal to number of days A and B both take plus 18, and number of days B takes is number of days A and B takes, because number of days A and B takes will be the lesser quantity, right? Plus 8. Okay, find the number of days they both take if they work together. Okay, this is a simple question. What we do is see, we consider number of days A and B both take as x. Okay, so we get n of A is x plus 18 and number of days B takes is x plus 8. So we know rate of A is nothing but 1 by the number of days A takes to complete the job, right? So that is nothing but 1 by x plus 18, and rate of B is 1 by n of B, which is 1 by x plus 8. Okay, knowing these two conditions, we know that rate of A plus rate of B is nothing but rate of A and B together, correct? And rate of A and B together is nothing but 1 by n of A and B. Okay, so for the simplicity of this question, we selected one n of A and B as x, so we get this as 1 by x. Okay, and rate of A is nothing but 1 by x plus 18, and rate of B is 1 by x plus 8. This is your equation in one variable, but it's going to be a quadratic equation. So now we cross multiply, we'll get x plus 8 plus x plus 18 whole times x is equal to x square plus 18 plus 8 is 26x plus 8 plus 6 is 144. Okay, so now we expand this, we get x square plus 8 plus 18 is again 26. 2x square plus 26x is equal to x square plus 26x plus 144. Cancel x square and 1x square on both sides, 26x, 26x. You get x square equal to 144, hence x is equal to 12. Okay, if x is equal to 12, then the number of days they take to finish the job together is 12. Simple. Next question. Three friends A, B, and C are employed to make pastries in a bakery. Working individually, they can make 60, 30, and 40 pastries respectively in an hour. They decide to work together, but due to lack of resources, they had to work on shifts of 30 minutes. Okay. Find the time taken to make 185 pastries. Okay. They decided to work together, but they had to work in 30-minute shifts. Okay. So we have to find out the time it takes to make 185 pastries. All right, now we find out the rate of working of the friends. So rate of A will be 60 pastries per hour, but they work in 30-minute shifts. So I want to calculate in half an hour how many pastries they can make. So this becomes 30 pastries per 30 minutes. Similarly, B will take uh, 30 pastries for 30 pastries in an hour, that is 15 pastries per 30 minutes. And then C will take 40 pastries in an hour, that is 20 pastries per 30 minutes. Okay, so if they have to finish 185 pastries, we'll say it starts with A. Okay, so A first goes first and makes 30 pastries in 30 minutes, and then the shift of A ends. That is what the question means. And then B, and then C, then again A, B, C, how many ever times it happens, and then you have to find out the number of minutes they take. Okay, so for the first shift of A, she makes he or she makes 30 pastries. Second shift B makes 15, C makes 20. So this adds up to 45, 65. 65 pastries done. Okay, then again there's 30, there's 15 and 20. Let's see if it exceeds. So 65 plus 65, it becomes 130, and you still have 55 pastries to go. Then again A goes and makes 30, so you have 25 more. And then B goes and makes 15, so you have 10 more pastries to go. And for C's shift, C only has to make 10. Okay, if C can finish 20 pastries in 30 minutes, it can finish 10 pastries in how many minutes? This becomes 15 minutes. Okay, so if we add up, we get 1, 2, 3, 4, 5, 6, 7, 8. 8 into half an hour plus 15 minutes is the amount of time it takes. So this is 4 hours and this is 15 minutes. So they take 4 hours 15 minutes to finish the whole batch of 185 pastries. Okay. The next one. A person employed a group of 20 men for a construction job. These 20 men working 8 hours a day can complete the job in 28 days. Okay. So basically 20 men working 8 hours a day can complete the job in 28 days. Okay, they start work. The work started on time, but after 18 days, it was observed that two-thirds of the work was still pending. To avoid penalty and complete the work on time, the employer had to employ more men and also increase the number of hours to 9 hours. Find the additional number of men employed if the efficiency of all men is the same. So basically, the scenario is 20 men worked 8 hours a day, and till the 18th day, that means for the first 18 days, only one third of the work was completed. Okay, one third was completed because two-thirds was pending. Okay, to avoid the penalty, he added more number of men and also increased the number of hours. Okay, so how we find this out is, see, if 1 by third of the work is achieved, by 20 men into the number of hours they work into 8, that is into the number of days they work for, that is 18. Okay, this is one equation. And another equation we get is 2/3 of the work is completed in the last 10 days. Okay, so 2 by 3 of the work is completed in the last 10 days where they work 9 hours a day, and it's not 20 men but it is 20 plus some x number of men, so that becomes 20 plus x. Okay, we need to solve these two equations for finding out, in fact this is not 1 by 3 but it's w by 3, and this is 2w by 3. Okay, if we divide the two equations we can cancel w, so we'll do that. Now w and w will cancel, 3 and 3 will cancel, so this becomes 1 by 2 this side. Okay, so 1 by 2 is equal to 20 into 8 into 18 divided by 10 into 9 into 20 plus x. Cancelling like terms, we'll get 9 2s are 18, and this 2 can come this side, this 20 plus x can go that side. So you get 20 plus x is equal to 2 into 2 into 2, 8 into 8, 64. So x becomes 44 men. Okay, so 44 men are added. That's what they're asking. Find the additional number of men employed. If efficiency of all men, yeah, we assume that. So 44 men were added. Okay, this is the equation. So here we don't consider work as one because we write it as some arbitrary constant w. Okay, where here w is the work. We can't tell in what units, but we'll still just consider it as w. Fine. The next question. 6 men, 10 women were employed to make a road 360-kilometer long. They were able to make 150 kilometer of road in 15 days by working 6 hours. After 15 days, 2 more men were employed and 4 more women were removed. Also, working hours were increased to 7 hours a day. If the total working power of 2 men and 3 women are equal, find the total number of days required to complete the work. Okay, so basically what we have to do is we again write the two equations. First equation will be they finished 150 kilometers. Okay, so 150 of the whole 360 kilometers into the amount of work that is applied, that is a constant again, w is equal to the work that men did plus the work that women did. Okay, here we know that if the daily working power of 2 men is equal to 3 women, okay, so 2 into men is equal to 3 into women. Okay, so then we can write everything in terms of men, so we'll get women is equal to 2m by 3. Okay, the rate of work. So here we can write work that women did plus work that men did is equal to 150 times work on the road divided by 360. Okay, 360 is the total length of the project. So this comes as number of men. Okay, the number of men in the beginning is 6 men. So 6 into number of hours they worked. Number of hours they worked was 6 hours a day into the rate of work, that is 2 into how much men work divided by 3. Sorry, into m because it's men. This will be plus number of women, that is 10, into number of hours into the rate of work of women, this, that is this. Okay, uh, now what we need to find out is after this they also told that the next half, okay, that means the remaining of the project, yeah, the remaining of the project is how much? 150, 360 minus 150, that is 210 into w by 360 is equal to, see, here they said that there were 2 men who were added and 4 women who were removed. Okay, so the number of men became 10 here, sorry, 8 here, okay, into the number of hours into the working power of one man, plus two women were removed. This becomes 8. Sorry, they worked for 7 hours a day, so this becomes into 7. So this becomes 8 into 7 into m. 8 into 7 into 2m by 3. Okay, these are my two equations. Now I have to divide and find out the working power of one man. Okay, so 360 can cancel, uh, and the work constant can cancel. So I get 150 by 210 is equal to 36m plus uh, this goes 2 times 20 40 m divided by 8 into 7 plus 8 into 7 by 3, 4 by 3 into 8 into 7 into m. So m and m can cancel everywhere. Okay, the next question. 6 men and 10 women were employed to make a road 360 km long. Okay, if they were able to make 150 kilometers of road in 15 days by working 6 hours a day, after 15 days, 2 more men were employed, 4 women were removed. Also, working hours were increased to 7 hours a day. If daily working power of 2 men and 3 women are equal, find the total number of days required to complete the whole work. Okay. See, 2 men is equal to 3 into women's working power. So to find the working power of one woman, we'll simply write it as 2 into m divided by 3. So we get this as W is equal to 2m by 3. Okay. So the first thing we have is here. Now what we need to do is 150 kilometers is equal to the work men did plus the work women did. The work men did is 6 hours a day into 6 men into working power of 1 man plus 10 women into 6 hours a day into working power of 1 woman. And this working power of 1 woman can be written as 2 into m by 3. So this and this cancels, this comes 2 times. So 150 is equal to 36m plus 40m. So it will be 76 into working power of 1 man. So 1 man can complete 150 by 76 kilometers. This is the equation. Okay. Okay, we get this working power of men in 15 days. Okay. So we can find out per day how much one man worked. Okay, we get that as 150 by 76 and divided by 15. Okay, so this cuts 10 times, so you get it as 10 by 76. Fine. Now we need to find out the number of days it took for the remaining 360 minus 150 kilometers of road to be built. Okay, because there was 360 kilometers total, you get the remaining road as 210 kilometers. Okay, so now we need to find out 210 is equal to number of days it takes into the number of men. Okay, the number of men increased by 2, so it was 6 before, it becomes 8 now. 8 into 7 hours a day into rate of 1 man per day, that is 10 by 76, plus number of days it takes into number of women. Number of women was 10. They 4 women were removed, so then it becomes 6 women left. 6 into 7 hours a day into 10 by 76 into, because this is m, and into 2 by 3, because that's the fraction the men work in terms of women. So we can take n common in both the sides. Sorry, in both the terms, you get n into 8 into 7 by 10 into 76 plus 6 into 7 76 into 3. So this is what you're left with, and we can cancel this 2 times. So n you get as, just going to crunch these numbers, So you get n as 210 by 210 by 19. Okay, so n equal to 19. Fine. Basically, it takes 19 days to complete the remaining part of the road. That is 210 kilometers. Okay. So the first part took 15 days. Second part took 19 days. So it takes a total of 34 days to complete. This was a bit tricky. Okay, next question. 3 men and 4 women can complete a work in 10 days by working 12 hours a day. 13 men and 24 women can do the same work by working the same number of hours a day in 2 days. How much time would it take for 12 men and 1 woman working the same number of hours to complete the whole work? Okay, first we need to understand that we need to find out the relation between the efficiency of men and efficiency of women. So let's write it. So see, the work they do is equal to the work men do plus women do. Okay, so number of men 3 into the number of days, that is 10, into the number of hours per day into efficiency of a man, plus uh, women 2, so 4 into number of hours into number of days into efficiency of a woman. So also one more equation is W is equal to 13 men into, they can finish this in 2 days, so 2 into 12 hours a day plus 24 women into M, sorry, efficiency of a man, 24 women into 2 days into 12 hours a day into efficiency of a woman. Okay, so you divide these two equations, LHS by LHS, RHS by RHS, you get 1 is equal to 30 into 12 into M plus 40 into 12 into W divided by 13 into 24 into M plus 24 into 24 into W. Okay, so if you see, you can cancel 12 and this 2 times and this here and this 2 times. Okay, more than this, yeah, so we'll just cross multiply. We will get it as 26M plus 48 women. The efficiency is equal to 30M plus 40W. So this and this will cancel. 8 women remains this side and 4 men remain this side. So basically the efficiency of 1 man is equal to the efficiency of 2 women. Okay. Once we have this information, we'll plug it into the first equation, or else we can simply, yeah, we can simply write down the last one as how many days would it require for 12 men and 1 woman to work, right? So work is equal to 12 men into working 12 hours a day into number of days it takes into efficiency of a man plus 1 woman into 12 hours a day into number of days into efficiency of a woman. So you get, we need to find out the n here, right? So from the first equation we can substitute, or we can simply write it again. We will get that W is equal to 12 into 30 into M plus 40 into 12 into W. Okay, we simply divide on both the sides again. Okay, you get 1 is equal to 12 and 12 can cancel everywhere. So you're left with, also we substitute M is equal to 2W here. So we get 1 is equal to 12 N into M plus N into W divided by 30M plus 40W. Okay, now we substitute M equal to 2W and then we can cancel M everywhere. Sorry, we can cancel W everywhere. So M is equal to 2W, you get this as W and this becomes 24, 24N. Okay, and this remains as it is. This becomes 60W and W can cancel everywhere. Then we take it this side. So we get 100 is equal to 24N plus N, so 25N. So n is equal to 4. So the number of days it takes is 4 days. Little tricky, but it's doable. Fine, the last question. 600 men can make a road in 500 days if they start working together after 100 days, 50 of them leave work. Find the total number of find the total time it takes to make the road. Okay, to understand this, we need to understand first something called work units. Okay, so basically, we need to first find out if one man is working, how much time does it take to build the whole road? Okay, so if 600 men work, they finish the road in 500 days. If one man works, he finishes the road in 3 lakh days because it is 600 into 500, right? So this is 3 lakh days. It takes him this long to finish the road. Okay, now we need to find out in every 100 days there are 50 men leaving the work. Okay, so for the first 100 days, so for the first 100 days, how much work is done? 600 days into 600 people, that is equal to, there is 60,000 units of work done in the first 100 days. Okay, then in the next 100 days, 50 men leave the job. So basically, how many are left is 550. Okay, so in the next 100 days, 550. So this is 5,50,000 units of work is done. Okay, not 5,50,000. Cut. Okay, so in the first 100 days, there is 600 into 100 units of work done. So this becomes 60,000 units of work done. Okay, so basically we have to achieve 3 lakh worth units of work. Now in the first 100 days, we did 60,000 worth. So we still need to do 2,40,000 units of work. Okay, in the next 100 days, there are only 550 people because 50 people leave and they do 550 into 100 units of work, that is 55,000 units of work. Okay, so we subtract 55,000 again. By now we are in 200 days. Okay, so this becomes 1,85,000 units of work remaining. Okay, in the next 100 days again 50 people leave, so we have only 500 people working. Into 100 is how much units of work they are doing, that is 50,000. Okay, so if 50,000 work is done, there is 1,35,000 work units of work remaining. Okay, in the next 100 days again 50 people leave, so 450 into 100 units of work being done per person, so that is 45,000 units of work being done. Okay, you subtract that here again, you are left with 90,000 units of work. Okay, again in the next 100 days, there are only 400 men working into 100, which is 40,000. So subtract this, you get 50,000 units of work remaining. Okay, in the next 100 days, 350 people work into 100, which is 35,000. Now we require only 15,000 units of work more. Okay, so in how many days will 15,000 units of work being done by 300 people? Okay, so 300 into x days is equal to 15,000. Okay, so 3 cancels 5 times and you can cancel 2 zeros here. So x is equal to 50. Now in another 50 days, the remaining work will be completed. Okay, so the total amount of days it took is 100 plus 200 plus 300 plus 400 plus 500, 600 plus 650. Okay, so 650 days are taken for the road to be built. Okay, this is a concept called work units. Okay, you need to break the work into a total big number. Okay, and keep deducting the numbers by as it is. Okay, so the question again was 600 men take 500 days to build the road. Okay, but they start working together, but every 100 days 50 men leave the job. Okay, so the number of days in total to make the road is what they are asking. Okay, by this we come to the end of the second chapter, that was called work and wages. Thank you for watching. I'll see you guys in the next chapter.